We are now going to look at a whole new topic. We're going to look at nuclear chemistry. So we need to introduce it here and see what is different between nuclear chemistry and all that other regular chemistry that we've been talking about through General Chemistry 1 and General Chemistry 2. So we're finishing off kind of with this idea of a whole nother world. So what is nuclear chemistry? Nuclear chemistry are reactions that involve the nucleus, okay? If you get those nuclei involved in the reaction, then it is a nuclear reaction. Every reaction that we have talked about up to this point has involved the electrons. The atoms come together and gain and lose or share electrons in order to bring stability. But when the nucleus gets involved, then we're dealing with nuclear chemistry. So let me go over to the computer screen here, and let's just, you see the definition in just an image there of and we'll talk about these alpha particles here as we go, where you start off with an atom, and this is just showing the nucleus. The electrons are way out there, but the nucleus loses a piece of it and it produces a new thing. So that it would be a nuclear reaction. So let's look at the nature of nuclear reactions here. As I said, the reactions that involve only the nuclei. When we are studying through this chapter, we're going to be looking at what's called radioactivity. Radioactivity is not the only type of nuclear reaction, but that's what we are going to focus on. But whenever you hear anything about nuclear transmutation, that's not in everybody's vernacular, but that's a type of nuclear reaction. But nuclear fission, nuclear fusion, these are types of reactions that involve the nucleus that we will not focus on in our time together on nuclear chemistry. This has got a lot of verbiage in it, but we're just going to walk our way through the difference in a chemical reaction versus a nuclear reaction. So atoms are arranged, okay, what it says here, atoms are arranged by the breaking and forming of chemical bonds. What are chemical bonds? Sharing of electrons. As I stated in my intro, it's only electrons that are involved when you are doing chemical reactions, okay? This is something I didn't mention yet, but the absorption and release of energy is relatively small. When we're talking about chemical reactions, we are usually talking in the amount of 100, 200 kilojoules per mole, all right? So it's not unusual to see a chemical reaction with in the hundreds of kilojoules per mole. Compared to a nuclear reaction, that is nothing, okay? Now, we dealt with kinetics in our chapter on kinetics. We talked about rates of reactions. Reactions in a chemical reaction were affected by temperature, they were affected by pressure, concentration, addition of a catalyst. Those are the things that we are familiar with chemical reactions. These are the things that are completely different than what happens in a nuclear reaction. So let's run through the nuclear reactions, okay? When you do a chemical reaction, however much hydrogen was there is still how much hydrogen was there. But when you do a nuclear reaction, you're actually converting elements from one element to another. So a hydrogen might get converted to a helium, or a uranium might get converted to a lead. So they're actually changed, converted when you have a nuclear reaction. So in chemistry, we talked about the law of conservation of matter, and we had to make sure we could balance reactions so that the same number of atoms are always present. That is not true when we are dealing with nuclear reactions, okay? In a chemical reaction, it was only the electrons, but when we do a nuclear reaction, we have got protons, neutrons, electrons, and other elementary particles that we haven't even defined yet that come into play when nuclear reactions take place. Now, I like the word tremendous here. In comparison to relatively small amounts, a nuclear reaction has a tremendous amount of energy that gets released or absorbed, okay? We will be looking at releasing energy. And lastly, when we talk about the kinetics of it, the rates, okay, These things are not normally affected by temperature, pressure, and catalyst. So we will circle the word not here. And we will consider the fact that they run in first order kinetics. Okay, something we did not mention over in chemical reactions is that we have first order, we have second order, we have third order reactions. We will always be seeing first order kinetics in our nuclear reactions. So I said that one type of nuclear reaction is radioactivity, so let us define that. Radioactivity is the spontaneous emission of particles and or electromagnetic radiation. Okay? If a nuclei spontaneously undergoes a nuclear reaction, then that is what we call radioactivity. Why would something do this? Well, it's because the nucleus of that atom is unstable. So if it's unstable, it will not stay the way it is. It will spontaneously try to get to a stable state by undergoing radioactivity. So what makes an isotope unstable? Well, there's several things that make an isotope unstable. But the easiest one is any atomic number greater than 83. And remember, atomic number is the same as the number of protons. If you get more than 83 protons in a nucleus, that nucleus is suddenly unstable. You've got far too much positive charge in a teeny tiny space, so that makes them unstable. There's other things that make them unstable that we will talk about later. All right, so the next lesson that we're going to deal with is being able to write nuclear reactions. Writing nuclear reactions is much different than writing chemical reactions. So that will be what you get to look forward to in your next video.